today's class. It looks like a lot of you guys are late today. So, please mute your mic.
It's a weekend.
Hello, Sisipo.
I text.
Okay. So I don't know, the others are a bit late today. But I don't know if we should wait or they'll catch up with us. I think let's start so that people learn to be punctual. Okay, sorry, I have a question for you guys. When are you writing your tests? How many weeks do you have left before your test? Hello? When are you guys writing your test? Are you guys not aware or? Okay, if I'm not mistaken, you guys have like 3 weeks left. Before that, move at a bit faster pace so that we have time to revise. Okay, so today we're going to be dealing with this. Somebody's mic is not off. Lizzie, sorry, please mute your mic. Thank you. Okay, so today we're going to be dealing with percentages. So from the word percent, let's look at it like this. It's percent. So when something says per, it means one of something, per something, per day, per whatever. So we're saying whatever it is, we're saying it's percent. So what is a cent? If I say somebody has 1 cent, which means it's 0.01. And if you remember from what we did in the first couple of lessons when we were doing the unit, hundreds, and I mean the tens and hundredths. So this is the 100th row. And remember what we said about 100th, it's 1 over 100. So this is basically where the word percent comes from. This is per cent. 1 cent is 100th. Okay, so that's just basically it. So everything in percentages is over 100. Okay, so if somebody says we have 80% of something, what they're saying is we have 80 over 100 of something. Okay, so you don't write percent like this. So this sign signifies over 100. Okay, whenever the sign is there, whatever they're talking about is over 100. Okay, so as you can see, this looks a lot like the fractions that we were doing the first time. So you can convert these to decimals, you can convert decimals to percentages, fractions, and stuff like that, because percentages are basically fractions if you think about it. Okay, so let's say we have an example and we have something like, okay, they are on page 24. They have an example there. They're saying convert half to a percentage. So remember what we said about converting fractions into decimals, but and decimals into fractions, things like that. It's gonna come into play because it's the same thing. So remember I said percentages, it's just 100, 1 over 100. So to change a fraction into a percent, we multiply it by 100, because remember I said this sign means it's percent. And if in maths, if anything is next to each other, there's an invisible multiplication sign. So if we want to say half percent, it means we're saying half times percent. And we said percent is 100. Okay, 100th. But like now we're reversing, we're not going the other way. So that's why we're multiplying by 100 and not 1 over 100. Okay. So we now say 2 into 2, we get 1. 2 into 10, you get 5 into 0, we get 50. So that's how you convert a fraction into a percentage. It also goes the same way for decimals as well. To change it into a percent, you just multiply it into a percentage, sorry, you multiply it by 100. So there's 20 here, so this means the comma is gonna move 1, 2 times. So which means we're gonna have 25%. So this means over 100. So now to go back from 50% to half, here, let's just say take 50% back into a half. We said this means it's over 100. Okay, so we have 5 over 10. If we reduce it into lower terms, 5 into 5, 1, 5 into 10, 2. So we've gone back to a half. Same way with the decimal, we have 0.25. So we said it's 25%, which means it's 25 over 100. Okay, so we just reduce this into its lowest terms. We can start with 5, and then we can say 5 into 25, we get 5. 5 into 10, you get 2, 5 into 0, and then you lower that again. Say 5 into 5, you get 1. 5 into 20, you have 4. So you bring it back to 1 over 4. But this is like lowering it as a fraction. But remember, we can just say 25 divided by 100 and move the decimal place twice. Just the same way we moved it this way, we can move it backwards again. And then we still have 0.25, or you can do what we usually do, 4 into 1, you get 0. You put a remainder 0 there. 4 into 10, you get 2, remainder 2, add that 0 because it's a 10th now. 4 into 20, it's a 100th actually. 4 into 20, you get 5. And then we have 0.25. Okay, oh, sorry, this part of the screen is not visible. All right, so that's just basically how you move back and forth between fractions and decimals and percentages. Are there any questions? So we're just gonna go straight to, okay, I think there's sentences, some examples with sentences. Let's do that first before we move to the practice exercise. Okay, so on page 25, part 1 says 49%. So when you're doing word sums, I advise you to take it step by step. What you hear, when you hear something familiar, like mathematically familiar, you need to take it down and put it on the side. So the first one says 49%. Before you proceed, from what we said that if you hear 49% in your head, you should be seeing this, okay? It's 49 over 100. So it's saying 49% of the population, of the total population in Africa are positive, are HIV positive. In a certain company, I'm not sure what this example is saying, 71% of the employees are male. This obviously means that, okay. So when they say 49% of the total population are HIV positive, they might ask you how much of the population is HIV negative. So that means now you're saying you want to find out. So this is a population, we'll call it X. And then they're saying this is 49%. They're HIV positive. So we want to find out the remaining half. So the full amount is 100. So we're going to say 100% minus 49%, and then we get 51%. So they usually kind of ask these questions, but they don't ask them directly like this. Yeah, so they'll give you a certain percentage of something and they want you to find the remainder or the percentage that they don't have. So the whole entire is 100%, and then you subtract the 49%. Okay. A group of 25 people contains 12 males. What percentage are males? Okay, so this is like what we just talked about now. Okay. So we know that the total number of the group, our denominator, the total number is 25. And they're saying that only 12 are males. So this is a fraction of males in that population. So now we want to change this fraction into a percentage. And remember, we said to change a fraction or a decimal into a percentage, we multiply it by 100, okay? And to change a decimal or a percentage, a percentage into a decimal or a fraction, you divide it by 100, okay? So here we multiply by 100 to change it into a percentage, okay? So we say 25 into 25, you get 1. 25 into 100, 25, 50, it's 4. And then we have 12 times 4, which I think is 48. So the percentage of the population that is males is 48%, okay? Because 12 out of 25 are males, all right? And then they ask again, what percentage of females? So there are two ways of doing this. The first way is you can either say, if there's 25 people in a group and 12 are males, how many are females? So now you're saying 25 minus 12, which is, I think, 13. So now you have to say 13 over 25, and you change that into a percentage. Same way here, 4, and then this times 4, 4, 8, 12, 2, which is 52%, okay? Or you can say we have 48%, so the remainder is going to be 100. So this is for males, and this is the females. So this means that 100, the females could also be the same as saying 100%, which is everybody, minus 48%, which is just the males, so that we can find the remainder, which is 52%. Okay, so you can choose between this method or that method, which is still yields the same answer. All right. So let's move to the knowledge test on page 26. Let's work through it together. Are there any questions before we start the knowledge test?
I'm good.
Okay. All right. Looks like a lot of you didn't attend today's class. Okay, so question 1 says convert 1A, convert to percentages. So those are fractions. So is there anybody who wants to help us convert 1/4 into a percentage?
Hi, it's Ndumi. I can try.
Okay, Ndumi, thank you. So how would we convert this into a percentage?
Okay, we're going to multiply it by 100. So we're going to say multiply by 100. Then we say 2 into 4 goes twice. Then into 10 goes 5 times. Then we've got 50 over 2.
Yes.
Which is 25.
Okay.
So it's 25%.
Thank you, Ndumi. That is very correct. Okay.
Thank you.
The next part is 1/8. So basically now we know how to do B and C from question 1. Okay. Because just like Ndumi explained, you multiply by 100. 8 into 8 goes once, into 10 once, remainder, is this a perfect fraction? Oh yes, it is. Remainder 2, and then you say 8 into 20. It goes in twice, and remainder of 5, I think, wait, a remainder of 4, sorry. Okay, 8 into 4 is 0, so we'll put a decimal point, okay? Because it doesn't go into 4, but it can go into 40. So 8 into 40 is 5. And our answer becomes 12.5%. Okay, And then C is 5/12. I'm sure you guys can try and work that one out, but let's just do it. 5/12 multiplied by 100. I hope you guys work these out with me on your pages as we go, because as you write something down, it's easier for it to stick in your brain. Okay, so we can start with 12 here. We can say 12 into 12, we get 1, or we can start with smaller numbers like 2. Then we have 6. Here we know it's 50. And then here we can also say 2 again. We have 3. And now we have 25. And then 3 into 25 doesn't work out. So now we have 5 times 25, which is 125, if I'm not mistaken. Okay, so
Yeah, it's 125.
So now we have 125 over 3. Okay, so we say 3 into 3, we get 1. 3 into 12, you get 4. 3 into 5, you get 1, remainder 2. 3 into 2 doesn't work out, so now we have a decimal point. Okay, and then 3 into 20 is 6, and remainder 2. So this one keeps going, actually. It's going to be 41.66666666666%. So, but since most percentages, 1 decimal place is enough. They don't go beyond 1 decimal place. Sometimes they have 2 decimal places, but 1 is usually enough. So here we can either have it as 41.67%, because we rounded off from the 666 that keeps going, or we can just have it as 41.7%. But I'll suggest that you take this one, 0.67, because it keeps going and going and going. So this reduces error. The more decimal places you have, the more accurate something is, the more accurate your number is. Okay. So unless if they tell you otherwise, when they start, like you need to round off all your answers to 1 decimal place or 2 decimal places, I would take this one, 4.67. Okay.
Tubelihle,
Hello.
it's Lizzie.
Hi, Lizzie.
Yes, ma'am. I don't know what to say, but like when we are doing C, we said 5/12 multiplied by 100. Then we started with 2 into
Yes.
12 go to 6. Then 200 goes to 50. Then
I was
we
doing that
left with
to use smaller numbers, but you can use 12 straight up, because it's easier when you start with smaller numbers, like 2, so that it's easier. Which part did you get confused when we couldn't divide 3 into 25?
I beg your pardon?
Which step did you get confused at?
Okay, it's when we get 125/3.
Okay, so let's do that. Here.
Yes.
25/3.
Okay, I get that. After that, if you say, I don't know when to say that 3 into 125, or you say 3 into 12.
Okay, so it's basically 3 into 125, but done into 12 and 5, so that it's easier for us to digest it, because it's a small number compared to a much, much bigger number. So we would have, saying 125 now, how many times do you have to count to get into 125? So that's why we start like saying 3 into 3, 1, and then you start with the first half. If you remember when we did the long division, actually, let's do it. When we're doing long division, you first divide into these first numbers, right? Before you get to this one, right? So we say 3 into 1, it cut. So the space remains empty. 3 into 12, okay? And how many, what do you get when you say 3 into 3, 6, 9, 12?
4.
It's 4. So you put your 4 here, and then you say 4 times 3, okay, which is 12. And we subtract that from 12, which is 0, which means there's no remainder here. And then we bring down 5, okay? And then we say 3 into 5. How many times does 3 go into 5?
1, then remainder 2.
Okay, remainder 2. So that means 3 times 1, you're going to get 3 here. So it's going to be minus 3, remainder 2. And then we say 3 into 2. It can't. So we put a decimal point.
Okay.
Then 0. So for us to add a 0 here to this 20, we need to add a decimal point. Okay. And then now we say 3 into 20. How many times does 3 get into 20?
6, remainder 4.
Remainder 4. Isn't it 18?
Remainder 2.
Yeah.
Sorry.
So it's 18 here, and 20 minus 18, you get 2. Okay. And now we're filling in the second decimal point. So we bring down the 0. So as you can see, it's going to keep going and going because we're going to keep getting 20, 20, 20, 20, 20. So it's going to just keep on giving us 6, 6, 6, 6. It's an unending thingy number. It's not gonna end. It's going to keep going 6, 6, 6, 6, 6, 6. Let's prove that it's going to keep going. Because how many 6s do we have? We have 2 now. Okay, so we said 3 into 20 here, you get 18 again, okay? And then you remainder 2, and then we bring down this other 0, becomes 20. 3 into 20 again, you get a 6, remainder 2. Here, sorry, I ran out of space. Remainder 2, and then we bring down this 0 from this column. So you see it's going to keep going because the remainder doesn't change. It's a remainder of 2. Okay.
I see. Now I get you.
Yes. So now we were saying that we're going to reduce the number of decimal points so that we don't have 4.666666666. Okay. We need just to have 2 decimal points or 1. Okay. So that's when we round it off. So we look at this number. If we want to make it 1 decimal point, we look at the 6. If we want to make it 2 decimal points, we look at the 6. Either way, we can have 41.7% or 41.6, and then this one changes 7%. Okay, is it clear now?
Okay. Yes, ma'am. Thank you so much.
Okay, you're welcome. Moving on to D, converts to percentages. Okay. All right. D is a decimal. Who wants to try and work out D for us to change 0.056 into a percentage? Is Kalani here today?
I can try, but I don't know if I'm correct. So
Okay, Kalani.
it's Kelvin.
Oh, Calvin, yes.
So because we are not to get a percentage, we always multiply by 100. But since we have a decimal number, the best thing is to multiply by 1,000 to get a whole number. I don't know if that's correct or I'm wrong.
All right. Thank you very much, Calvin. We always multiply by 100, even
To get a
if
percentage.
we're going to end up with a number less than 0. Even if it was 0.00006, we'll still multiply by 100 because that's what I was saying when I was introducing the topic. Whatever happens, it's percent. It always has to be 100. We always multiply by 100 because it's per cent. Percent means of something. 1%. It's 1 per 100. Okay, so cent is 100. So every time, no matter what it looks like, even if it's too big or too small, you always multiply by 100. So what would your answer be here, Calvin?
It should be 0.56%. We're
Are you sure?
multiplying by 100 because we are moving 2 decimal places, so it becomes 5.6. Yes, it's 1 and then 2, so it would be 5.6%.
Thank you very much, Calvin. That's correct.
Thank you very much, today.
So you just multiply by 100 always, no matter what the situation is. If it's percentages, if you just hear the word percent, okay, it's just always going to be divided by 100 or multiplied by 100. Okay, so E is 0.43. Who wants to try this one out for us? Change 0.43 into a percentage.
It's in Dumi. So we're also gonna multiply by 100.
Yes.
Then it will give us 43% because we're moving to
decimal
places, yes, to the right.
Okay. All right, thank you, Dumi. That is correct. Okay, so the same goes for the last one there on F, 0.916. You move it 2 decimal places and we have 91.6. That's correct. All right. So now we are reversing. This whole time we were converting fractions and decimals into percentages. And now we want to reverse this procedure, going back. Okay. Remember I told you if you see that sign, means whatever it is over 100, be it a fraction or a decimal. Okay. So 2A has 59.5%. Who wants to give this one a try? We want to change 51.5% into a decimal.
I think the inverse becomes true. We still multiply everything by 100, or we divide everything by 100 because it's already in percentage. You want to take it a decimal, so we divide by 100. Yes.
Yeah. Remember I told you when you see the sign, it means that it's a multiplication sign. So I told you that this percent is 1 over 100. So we're basically saying 59.5 times 1 over 100, because this is what the sign means, percent. It's 1 over 100, which is why we just basically divide by 100. Okay, because it's like this. All right. So we're changing it into a decimal. So this time we're moving the decimal place to the left, not to the right, because we're dividing, we're not multiplying. Okay, so we move this one once and twice. So we have 0.595. Okay, so if they were to say change this into a percentage, you'd multiply it by 100 and you'd move the decimal point 2 times, 1, 2, and you'd have 59.5%. Okay, who wants to try out B to convert 12.5% into a decimal?
Okay, I'll try it. So we're going to divide it by 100. Then we move 2 decimal places to the left, which will give us 125%.
Are you sure? Which side are you moving? To the left or to the right?
To the left.
So if you move to the left, 1, 2, what do you have?
0, sorry, it's going to be 0.125.
Yes, that's correct. Okay, and then changing it back, you'd have to move it twice again. 1, 2.
To the right.
All right, thank you so much, Shindumi. Okay, Calvin, do you want to try out C? 290%.
Yeah, sure, no problem. C is 290% converting into the decimal. So we say 290% over 100. And then we move the decimal places 2 times to the left.
1, 2. So what do you have?
2.9%.
Yes, that is correct. So you'd have 2.90 as your final answer. Okay, so does anyone have any questions about converting percentages to decimals? So from decimals, it's easy because now you just have to move decimal places. It's not the same as fractions where you have to divide a lot and stuff. You just move the decimal place, okay, twice or once. All right. No, sorry, twice. You always move it twice in percentages. The question is, are you moving it to the right or to the left? Right. And then this one, we're saying converts to fractions. Okay, 3a. Who wants to try out 3a, 22.5%? Can we change this into a fraction?
I think I can try 22.5. So we say 22.5 over 100.
Mm-hmm.
I think the first thing to do is to there are two ways. I think either we can deal with the number without focusing on the decimal, or we can deal with it with the decimal. So, but I think, yeah. So I think what we just do is we just did
Get
with.
rid of. You want to continue with it?
I think I would get rid of it. I would move the decimal places, like.
All right.
Yeah,
So now you have
great.
225
Over
over.
1,000.
Yeah. So how would you change?
Then I'll simplify it by maybe using 225 into 1,000. Just because we now have to simplify the math so that it becomes a fraction. 1,000 divided by 225.
Remember, I discouraged you from using
So yes, so it
calculator.
can't. Yes, so it can't. So what we then do is we can use 20 as a no, we can use 5 to break it down first. So we can say 5 into 25 is 4. Remember 5. Remember 2.
225.
Yeah, 225. So I'm using 5 as a basis to start. I know
Okay.
it's a bit longer, but it's easier for me.
It's
5
so
into
fine.
20. 5 into
So
22 it becomes 4.
mm-hmm.
4
Remainder.
4 remainder 2. 2 into 25
Mm-hmm.
that's 5, so it becomes 45.
Mm-hmm.
5 into 1,000 is 200, so it becomes 45 over 200. Yes.
Mm-hmm.
So it becomes 45 over 200. Then we can still simplify it using 5 again. 5 into
Mm-hmm.
45, that's 9.
Mm-hmm.
It's 9, and then 5 into 20, that's 4, so it becomes 9 over 40.
Okay.
Yes.
Do you think it needs to be simplified further than this, or this is the final?
I think this is the final. Yes.
All right. Thank you so much. This is correct. So this is the fraction. This is the fraction that represents this percentage. Okay. And to move this into that, we just multiply this by 100. Okay. So who wants to try out B for us? 66.7% into a fraction. Hello, guys. Remember, we're trying to move fast so that we can cover a lot of ground before your exam comes. Who wants to try out 66.7%? Should I pick out somebody? Doris? Is Doris here? Doris, do you want to help us change 66.7 into a fraction? Hello. Okay. So let me just try it out for you guys. 66.7 over 100. Okay. So you can either get rid of the decimal place or you can keep it, but I prefer getting rid of it. And remember, I said when you want to change a fraction, whatever you do to the denominator, you have to do to the numerator. So if we decide to multiply this by 2, we have to multiply by this by 2. It still maintains the same mathematical value because anything over anything is 1. So that's why we're saying here times 10 over 10. This is 1 because 10 into 10 is 1. So that's why we're multiplying it by 10. We just want to get rid of the decimal point, but the value of the thing, it doesn't change, of the sum. So we now have 667 over 100. So now you just basically have to find common factors. Oh, sorry, over 1,000, not 100. You have to find common factors between these two. Okay, I'm not sure if this is a multiple of 2. Let's see if it's a multiple of 3. It's not a multiple of 3. It's not a multiple of 4 either. Divided by A. Okay, so it seems like this is actually the fraction because there are no common factors between 667 and 1,000. 2 can't go in, 3 can't go in, 4 can't go in, 5 can't go in, 7 can't go into both of them. So this is it. This is the lowest common factor. So you can leave it as 66.7 over 100, but this is actually more preferable because it doesn't have a decimal point, okay, and it's a pure fraction. All right. So if you don't find factors between them, that's okay. You can just leave it as a fraction of 100 or 1,000. Okay. So I think that's it. Is there anyone with any questions on what we've done so far before we do the story questions, question 4 and 5? All right. So question 4 says, in a class test, student A scored 58 out of a total of 90. Student B scored 67 out of a total of 110. And the question says, who performed better? So now we need to know, we need to change these into percentages so that we can see who has a higher percentage between student A and student B. Okay, so remember we said to change anything, a fraction or a decimal, into a percentage, you always multiply by 100. Okay, here we're also gonna multiply by 100. Okay, so there we can start by canceling out the zeros. And then is 3 a multiple of 58? It's not, is it? Let's see. Okay, this one is going to have decimal points. It's going to have a lot of decimal points, so we can just bring it here as 580 over 9. So we can say 9 into 9 goes in once. 9 into 58 goes in, sorry, 5 times.
6 times.
So what's the remainder? 6 times 9.
The remainder is 4.
Okay, thank you. 6 times the remainder is 4. So 9 into 14, 9, 18, 27, 36, you get 4. Remainder, 4, I'm guessing.
4,
And
yeah.
1.9 into 40, you get 4. So you see, this is
4.
just like the one that we dealt with, the 1.66, because this one is going to keep going 0.44444, because you can already see all the remainders are going to be 44444. So this student A got 64.6%. Let's see how much student B had. So we can cancel out the zeros here. And then we have 670 over 11. 11 into 11 goes in once, into 67, goes in 6 times, remainder 1. 11 into 10 is 0, comma, am I correct? 670 divided by 11. Yeah. So remainder, so 11 into 10 is 0. Remainder, oh no, now we just add a 0. 11 into 100 is 9. We have 99. 99 minus 100 is 1. So now we have also another 11 into 100. So, sorry about that. You get 9, remainder 1 again. So you can see over this, it's 60.999999. Okay. So which means this is basically 61%, but we can leave it as 60.9%. So between student A and student B, who do you think did better? Student A had 64.4%, student B had 60.9%. Who do you think performed better?
Student A.
Yes. So that's how you come to your conclusion, and then you write a sentence here. Student A performed better than student B. Okay. So that's just basically how you would solve the story sum. So like I told you, when you're dealing with story sums, always try and write down what you heard or what you're understanding from the sentence as you go. Okay, because sometimes once you read the whole sentence, it might confuse you when you get to the end. So write down everything that you're hearing or you're getting from the sum or from the question as you go. Okay, so question 5 says, a sample of 500 people. So you already know that whatever we're going to talk about has a total of 500 people. So it consists of 56 whites. Okay. So we can say whites, says there's 56 whites out of 500 people. The next part says there's 43 Indians. Okay. And then the last part says 12 colors. And the rest are black. So they do not tell us how many black people there are. Determine the percentage of each race group in the sample. Okay, so basically we're just changing these into percentages. 56 over 500 into a percentage, 43 over that. And then for this one specifically, remember I told you there's 2 ways of finding this out. You can either say 56 plus 43 plus 12, and then you subtract it from 500 to find out the remainder. Or you can say whatever percentages you're gonna get here, 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 add them and subtract them from 100 to find out the remainder here. Okay, let's do that. So we have 56 over 500 times 100. Can cancel out these 2 zeros. And then we have 5 into 56. 5 into 5 is 1. 5 into 5 is 1. 5 into 6 is also 1. Remainder 1. 5 into 10 is 2. So this is 11.2%. Okay. And then this, if we multiply it by 100 as well, we cancel out the 2 zeros. 5 into 40, 0, it's 0 here. 5 into 43, I think this should be 8, if I'm not mistaken. 5, 10, 15, 20, 25, 30, 40, yes. Remainder
Yes, it's
3.
8 carried 3.
Yes. And then now we have to put a decimal point. 5 into 3 into 30, sorry, is 6.
6.
Okay.
6.
So we have 8.6% here. And then we come down here and we say multiplied by 100. Cancel out these 2 zeros. 5 into 5 is 1. 5 into 12 is 2. Remainder 2. 5 into 20 is 4. So this is 2.4%. Okay. So here now for the Black percentage and population, we can either say method 1, we can say here on the corner 56 plus 43 plus 12. You get 6 plus 3, 9, plus 2, 11, 1 carry 1, 5 plus 4, 9, plus 1, 10, plus the 1 that we carried, 11. So this is a total amount, 111 of the combination of white, Indians, and coloreds. So for find the Black people, now we're going to say 500 minus 111. And we get 389. Okay, so this means that we have here 389 over 500. Okay, and then we say this times 100. Sorry about that. We cancel these 2 zeros. 5 into 5, 1. Into 38 is 7. Carry 3 into 39. Also another 7. Carry 4. And then 5 into 40 is 8. Okay, so this is 77.8%. All right. Or you could have said, you could have added the percentages and subtract them from 100. Okay. So we could have said here 11.2 plus 8.6 plus 2.4. Let's add that. 6 plus 4 is 10 plus 2, 12. So it's 2 carry 1. 8, 10, 11, 12. 2 carry 1. So this would be 22.2%. So if you say 100 minus, 22.20. So there we get 8, but we borrowed 1 there. And then we borrow another 1 there. And then we have 10 minus this, we have 7. Also from there, we have 7. And then you get 77.8%. So you can choose whichever method feels easier or quicker for you, but it still yields the same percent. So you can add the population of all the other races, white, Indian, and colored, say 56 plus 43 plus 12, you get your total of 111, and you subtract that from 500, which is the total number of population, so that we can find just exactly how much Black people are in the population, which is 389 people. So 389 people out of 500, and we change that into a percentage. Or we can say this, this, and this, we add them, and we subtract them from 100, and then we get 77.8%. Okay. So that's it on percentages. Is there anyone with any questions on percentages so far, so that we can just start off with like the basics of algebra, and then we'll continue from next week.
I'm good from my side.
Okay. Anyone, any questions? Okay, so that's just basically it about percentages. Just remember, if you're converting a fraction or a decimal into a percent, you multiply by 100. If you're converting a percentage back, you divide by 100. Okay, into a fraction or into a decimal. All right, so let me just give you a quick rundown on algebra. Okay, I'd be lying if I said I knew the meaning of this word, but I think it's derived from like a Latin word. I'm not sure what it actually definitely means. Okay, so but I'm sure they put the background definitions here in your manual. So please this week, can you just use a couple of minutes of your day to read through page 29 there with the definitions and the example? Okay, so basically what I know about algebra, it's math with letters. Okay, if you think about it like that, it's not that hard. So usually sometimes you don't really know a certain amount of something, and you have to represent it by X or Y, basically a letter. But that letter is uniform for everything that it actually represents. Okay, like for example, we could say somebody bought 3 crates of eggs, and then we don't know how many eggs are in 1 crate. So we can say therefore X will be a crate of eggs. Okay, if somebody asks you how many, you bought 5 crates, so what's the total amount you got? It's 5x, 5 times x. So this x is, instead of writing 5 crates of eggs or whatever it is, if you don't know the specific number, or even if you do, it's easier to represent it with a letter sometimes to help you solve it easier. Okay, so the basic rules that I can give you right now before we go any further is that letters that are different do not add each other or subtract each other. Let's say we have 5x plus 3y. These are 2 different variables, x and y. They can't be mixed because we do not know what they are. But variables of the same letters can be added. If we say 5x plus 3x, you get 8x. 8x minus 3x, you get 5x. Okay, and the rules still apply, the same rules for addition and subtraction. Remember those rules? They still apply, like saying 3x minus 8x. When I said when the signs are different, subtract the smaller number from the bigger number and put the sign of the bigger number. The sign of the bigger number is minus. Subtracting 3 from 8, you get 5. So the signs, the rules of the signs still apply. So as I was saying, you cannot add or subtract different variables, but you can multiply them. You can't divide them, but you can multiply them. Okay. So let's say, for example, here we have 5x multiplied by 6y. Okay. We multiply 5 times 6, we get 30. We multiply x and y, we get xy. Remember when I was telling you that if you have xy, it's just the same as saying x times y. Okay, so they can only multiply. Different things can only multiply. You cannot add or subtract them. Okay, so I think that's basically the main rules that are there. And then the other rule says when you are adding, you put like terms with like terms, unlike terms with the unlike terms. Okay. So what I mean by that is if we have 3x plus 7n minus 2 n plus 5x. Okay. So first of all, you put the like terms and the like terms together. Okay. Because sometimes if you can pick it out with your eyes, you can just easily add them. But I would advise you to put like terms next to each other for easier referencing. Okay, so it's going to be 3x plus 5x plus 7n minus 2n. Okay, so now you've basically put the like terms together and the unlike terms together. You've basically put them together. So from what we said like terms can add each other. So basically here we have 3 plus 5x, which will give us 8x. Okay, 7n minus 2n, we're going to have plus 5n. Okay, this will be your final answer because you can't simplify this statement any further because they're not multiplying, they're just adding and they're unlike terms. So this is as far as it goes. Okay, so another example, okay, so that's just basically it in algebra. Okay. So algebra and an equation, this is just a brief rough draft before we can properly get into it next week into more broad examples. But I just want you to have a basic idea of how algebra works. Okay, so let's try it out in an equation. On page, there's an example there on page 30. It says 3x plus 6 is equal to 5x minus 2. Okay, so the same way that I said you have to group like terms and unlike terms, the same thing that we have to do here. So we can see that 3x and 3x are the same. This 6 and 2 are the same because they don't have any coefficient. By the way, this letter is called a coefficient. A letter next to a number in maths is called a coefficient. Even if it's just a letter, even if it's just x or y, the coefficient is 1. Because remember we said anything in maths is times or divided by 1. Okay, or to the power of 1. Okay, so now we have to move these across the equal sign to match. But here's a catch. Anything that jumps the equal sign changes its sign. Okay, so we can choose to either put these ones this side. We can choose to have the x's this side or the x's this side. So I'm gonna choose to put the x's this side because I can already see that 5 is bigger than 3. If I move it this side, we're going to have negative. It's still going to be fine, but it's kind of tricky to work with, okay? So I've chosen to put whole numbers this side with no coefficients. So that means we are moving to the side of the equal sign, and we are moving 3x this side of the equal sign. So that means we're going to be left this side with 6. Remember, I said anything that jumps the equal sign changes signs. This is a -2, but because it has jumped the equal sign, it's going to become +2. Okay, 5x didn't move. Okay, and then 3x is jumping from this side to this side. It was a positive 3x, but because it's this side now, it's going to become a negative 3x. Okay, so now try this. We have 6 plus 2, you get 8, is equal to 5x minus 3x will give us 2x. Okay, so mostly to solve this equation, we need to find the value of x. And to do that, we usually just divide by the coefficient so that we're just left with just x only. Basically, we're trying to remain with 1x. So if you divide with whatever number, that will be the coefficient. Anything into anything is 1. So we'd basically be left with 1 here. So 2 into 2, 1. 2 into 2, 1. So we basically have 1x here. Okay, so our answer is now going to say x is equal to 2 into 2, there goes in once, into 8 goes in 4 times. So we're left with 4 is equal to x, but it will be preferred to write it as x is equal to 4. Okay, so I'm just going to stop today's lesson here, but that's just the basics and the briefs of algebra. You can only add terms with the same coefficients, and you can multiply them as well, but you cannot add or multiply numbers or terms with different signs. So for now, we're only doing addition and subtraction of these and equations, but maybe next week we're going to get into multiplying them and things like that. Okay, so please go on ahead and try.
Hi, Tobe.
Hello.
Hi. Would you be able to give us like another example that we can do something similar to this that we can do now before we close off?
Okay. No, this was just an introduction because we have run out of time for today, but I'll give you one other example.
Thank you.
Okay. All right. Before we get into simultaneous equations, let's just work with them one by one. Okay. Okay, so we can have 8y minus 3 is equal to 2y plus 3. Okay. So the first step, remember I said, is to identify the like terms and the unlike terms. So the terms with y, we have this one and we have this one, okay? And our mission is to make sure that they're next to each other or they're on the same side of the equal sign, okay? So to put these on the same side of the equal sign, let's choose to move the y terms on this side of the equal sign and then the non-y terms on this side of the equal sign, okay? So that means we're going to have 8y here. So we're moving this y term from this side of the equal sign. Remember, if anything jumps the equal sign, it changes its sign. Okay, so it was a positive 2y, but because it's jumping the equal sign, it's going to become minus 2y. Okay, and then this side we had 3. It's not changing, but then we're moving this 3 from this side and we're taking it this side of the equal sign. So it was a negative 3, but because it's jumping the equal sign, it's going to become a positive 3. Okay, and then now we simplify this. We said like terms can add or subtract each other. Okay, so 8y minus 2y will give you 6y is equal to, and then we have 3 plus 3 here, we have 6. Okay, so remember we want to be left with y. We want this to be the subject of the formula. So when they say make y the subject of the formula, make x the subject of the formula, they're saying leave the sum as x is equal to, y is equal to, z is equal to. That's basically what they're saying. So how do we make sure that this y is left on its own? We divide both sides of the equal sign. So remember what I was telling you that in maths, whatever you do on the top, you do it at the bottom. Whatever you do this side of the equal sign, you do this side of the equal sign, okay? Here, we just say it's jumping the equal sign, but in actual fact, what we are doing, the reason why it changes sign is that we are saying for 8y, there was, okay, we're moving 3 from this side to this side. So this side, we are adding 3, and this side, we are adding 3. We've done what we did to the side of the side. But if we add minus 3 plus 3 is 0, so it cancels out. And then this side, it becomes a positive 3. The same way with 2y. We are subtracting 2y this side and subtracting 2y this side. Okay, plus 2y minus 2y cancels out this side. And then this side will just be left with 2y. So that's basically what will be going on. But there's no need for you to know. You can just memorize it as saying this one is skipping the equal sign. But basically the rule in math is whatever you do to the left side of the equal sign, you do to the right side of the equal sign. So if we're going to divide by 6, the left side of the equal sign, we're going to divide by 6 on the right side of the equal sign, okay? And then it cancels out. And then you're just left with y is equal to 1. Okay, so don't worry if you are getting a bit confused and things like that. Just go and read on algebra and we'll start on it properly next week. And we'll work on it properly next week, okay? Just remember that like terms add each other and like terms don't interact with each other, okay? And just first step always is to group the like terms, okay? Hello.
Yes, thank
Okay,
you.
yes,
Thank you very much,
thanks,
Thobeka.
Thobeka.
All right. See you guys next week. Enjoy
Bye.
your week.
You
Bye.
too.